Let's do a new exercise, sheet metal enclosure in Solidworks. This is our 2D drawing. Now let's read all dimensions on millimeter. Part to be free of burr, chips, break all sharp edges unless otherwise specified. All bend radii to be 2 mm unless otherwise specified. 2 mm thick 5053 H2 aluminium alloy. Okay, there is some mistake. Relief cut angle, relief cut 50%. Okay, this is the bend diameter, this is the flattened view. Now this is our top view. So we will start with top view. Now side view, there is also one side view, there is a bottom view. So just check this bottom view. We will start from bottom view. So you look width and height, look these cutouts, you will see these actually a kind of width, and length is already given here 100. So 120 by 100 we are going to make one. Then we will draw these flange. This flange height you will see 40 millimeter here. This flange depth inside, we will keep depth inside. Okay, and thickness 2 millimeter fine, radii also 2 millimeter. Now I am going to activate top plane sketch. Now activate here center rectangle and click on origin point and drag. Now here let's say 100, tab key, 120, enter. Right click, exit. Now go to sheet metal, right click on any tabs, go to open tabs, and here you can activate it from here, sheet metal tabs. Now first we have to create a base flange. Let's activate base flange. Now look, material goes downward, 2 millimeter thick, change direction, I want to keep inside. K factor I'll keep standard 0.5, we will learn some other time. And here rectangle ratio, now this is 50% means 0.5, 1 means 100%. Okay, if you uncheck then you can apply the dimensions and everything, but we will go for relief ratio. Okay, now if we choose 0.5 here means this will remain constant for all the design for. Okay, now activate edge flange. Now I am going to click this edge, drag your mouse, similarly do for this. Now let's check side view, not this side view, this one. Okay, now angle I am going to keep 2, radius everything by default 90 degree, the angle between these two flange 90 degree. Now depth I want to make it 40. Okay, 40 from bottom to top. You will see here from virtual sharp. Virtual sharp means the intersection point between these two outer edges here somewhere. Now material I am going to keep inside according to drawing, outer distance 100. This one no need to define. Cut relief if you are going to check, 0.5 by default, say okay. Now you will see there one more flange, these flange height also 40 millimeter. Okay, according to this drawing, but you will see this distance we took 120 from here to this corner. Now here 6.1 millimeter add, you will see here thickness 2 millimeter. This is bend radius always 2 millimeter, we keep 2 millimeter. So 2 plus 2 is 4, minus the remaining is 2.1, we keep this one 2.1 in both side, 132.2. Okay, let's do it. Edge flange. Now select this edge, drag your mouse upside. Now select both the edges. Now let me first angle 90 degree. Now depth or height 40, that's same. Virtual sharp. Now material I am going to keep here, flange position, bend outside. Now let's check which side. Let's check not this one. Okay, you will see material bend going to add from this edge. You will see the arrow. Here I am going to keep offset, and here let's say these 6.1 minus 4, it's going to 2.1 millimeter both side. Now relief angle, if you are going to check 0.5 ratio, say OK. Now let's check. Now select this face, hold shift key, select this face. Now check at bottom right normal distance. See here 132.2. This is our goal. Fine. Now see there is a 12 millimeter depth and this is equal to this face. Okay, this is the things. 18 millimeter depth. And this is going to start from this edge. And there is a simple cut relief. This one we will create later. The hole we will make, there is a rectangle hole, this one we will make later. 5 number of holes, 4 number of holes, 5 rectangle. Edge flange. Now I am going to select this, drag here, edge flange. Smart dimension, let's make this depth 12 millimeter. Okay, back. Now here angle 90 degree to this flange. Now bend length or flange length is 18 millimeter. Now let's check some view, not this view. Okay, this view. Now look, I want to be uncheck material inside. See, material goes inside front. You will see there is a chamfer. 0.5 ratio. That's it. Okay. Look here. Now let's do it. Either you can mirror this, but in sheet metal I want to prefer mirror. I will do manually. So let's do the silently. Now here we done. We did all these things. Now you will check there is one more bend. See, these bend depth 20 millimeter. Okay, what exactly these locations? Let's check. Okay, you will see from here. Look, this is parallel to this end. Simple. All 4 corners you will see in dotted line. And these also have chamfer. Look, in cutout view, flattened view, you will see these have chamfer. This seems something like this. And you will observe from here these bend outside. Okay, let's activate edge flange and I am going to select this edge, drag. Now let's say top view. Okay, now let's make angle 90 degree, radius everything same. Now here flange length 20. Okay, now material I want to keep outside, bend outside. See, bend outside. There is a very small gap between this. That's why these length 6.1. There is only 0.1 mm gap between these two, because these two are going to tap weld, spot welding between these two. Relief ratio 0.5, that's it. Now let me select all the edges inside. Now this is symmetric geometry. Okay, let's check on top view. Okay, that's fine. See, now let's make there is a cutout. You will see these cutouts. Now here length 54, radius corner radius R8 means 8 plus 8 is going to be 70, depth of this 25 and 5 millimeter from here. And if you calculate from this end 39.1, this is exactly at center we will do, and this side 34 plus 16 50, 25 5 millimeter from here. This is also going to be, let's say, 110 minus 33 33. If you select this 50, so 33 minus 8 is going to be 25. So this is also at center. Then there is some holes also. You will see here 5 diameter, and there is 8 hole 4 diameter. This one 40, distance 10, 40. So 10 here, minus 100 is going to be 80. Okay, this is also you will observe at center. Once we calculate, we will see these two middle one 50 50. This is also lies at center. If you calculate from this distance 41, 132 minus 41 41, so you will observe this location also. And there is a 4 hole 77, and this hole we will make later. Now first we have to use flatten. Unfold, select this as a base, fixed base. Now calculate all bend. Okay, now this is open. Now we will make all the holes and everything together. So select this face, sketch. Now I am going to here activate center rectangle. Now 25 tap, 70 enter. Similarly, let me draw one more here. This is going to be 50 tab 25. Okay, fillet, make it 8 millimeter. Now select all. Okay, cancel. Let's make important relation. Now select center point and origin point horizontal, this vertical, and this point vertical. These are the constraint, important constraint. 5 millimeter. Look, this is fully constrained. This is fully constrained drawing. Fine. Because I want to mirror this one here. Here is 0. So go to mirror entity, select this all. Mirror about this line. Okay, that's it. Now let's go to sheet metal and here activate extruded cut. Now for blind condition, keep blind and select link to thickness. If you don't want, just uncheck and apply the dimensions, but better to click link to thickness. This is going to cut only up to thickness. Look, again sketch. Now I am going to create rectangle. Now first rectangle 50 by 50, enter, and make sure here select construction. This is for reference purpose. Fine. And there is upper one 80 tab 40, enter, and here also select for construction. Fine. Hole. This is going to be 4 millimeter, and this is going to be 5 millimeter. Okay, let's exit. Okay, let's make the important relation. Now select first center one. Select these four holes. Press and hold shift key. Select these four holes. Once you leave shift key, you will see this pop up or equal. Now similarly do for outer holes. Select all four outer holes. Equal. Okay, there is some more holes also, 108. Okay, let's make one more rectangle. This 77 vertical, tap 108, enter. Make sure for construction, okay, hole. Add here one more hole. Right click, choose select and out. Now select all the holes and select this outer hole because diameter is same. Once you leave shift key, you will see this pop up equal. Go to sheet metal, activate extruded cut feature and similarly keep blind and here check link to thickness. See, the hole is created. Now let's say fold feature. Now base already selected this one. Now bend to fold. Even you can manually select, there is a line, see. You can select, but it will take time. So simply choose collect all bends. Okay. And here we go. Now the whole problem solved. Now there is a chamfer. Look, 3 by 45 degree. This is the chamfer, 24 numbers. Means this all including here also and including this internal rib also. You will observe in flattened view. See, chamfer. Now activate here break corner trim. Now here choose first chamfer 3 millimeter. Now here either choose one by one edge or even face also work. So let's say I'm going to select this face. See, automatically it detect corner and apply here. Similarly I'll do for this. Similarly do for this. And similarly do for this. See, these and we need. Let's say this end. See, if I am going to select this face, it will detect both corner. Similarly this face. Okay, let's time to rotate. Fine. What else balance? Okay, there is one face. Just check anything remaining. Okay, we selected all the edges. 3 millimeters, say okay. If we choose flatten view, select this face, normal, and you will observe. This is what our requirement. Now only few holes balance. Uncheck flatten. Now there is a square hole 5 millimeter. You will see these hole 9 millimeter from here and this is lies at center. See, 12 minus 5, so 3.5 one side, 3.5 one side. It's going to be at center. So let's do this. Now select this face, sketch, rectangle. Now 5, tab 5, enter. Right click, exit. Smart dimension. Now from this edge 3.5. Fine. Now distance from here to outer edge 9. Okay, let's activate center line and we will mirror this vertical horizontal. Mirror entity, let me select this all. Make sure you selected copy. Select this line. You will see the preview. Okay. Again activate mirror entity. This time I am going to select these all holes. Mirror about this horizontal line. You will see the preview. Okay. Now activate extrude cut feature and here choose link to thickness. Okay. If I am going to check top view, see the holes are exactly lies at center, the bottom holes. This is what's shown in drawing. Now the material, I think we finished all, nothing left. Now look, spot weld tab to box. There is a spot weld between these two, all four corners. Now here you will observe bending table. It will show you all the names A, B, C to M. Bend down 90 degree. There is an inner radius 2 millimeter. See, these all bends by dotted line. So this is the drawing for development. Let's say add material. Okay, material, this aluminium alloy 5053H32. Okay, then this is powder coat black. Now if you, or let's apply material, right click, edit material, go to aluminium alloy 5052H32. Apply, close. Look, I want to edit appearance for this. Okay, save. Enclosure, that's it. Now let's say open, flatten, right click, and from here you can export to DXF drawing. DXFC, save as, save. Now here choose sheet metal, export sheet metal. Export, you want to export hidden edges, bend line, sketches we don't need, forming tool, bounding box. Okay, let's say bounding box. Okay. Look, this is your 2D drawing. Now these drawing you can use in Autodesk or any machining work like CNC cutting. You can simply save. That's it. Uncheck flatten view. I hope you like it. Don't forget to share, like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.